I have been working on the art and science of conservation for 35 years, and I've learned a lot along that way. And I want to share some of those lessons, but really those lessons have changed quite a bit with the last 10 years of work that I've done in the Arctic. So the Arctic is giving us a few key lessons, and I'm going to share those right at the beginning. We need a much greater sense of urgency. What's happening in the Arctic is calling for much greater levels of urgency. We need new conservation tools. You just heard about thickening ice. That is a conservation tool in the 21st century. We're going to need many, many more. We need new ways of thinking about what conservation even means. It certainly isn't the concept of creating parks and protected areas and setting them aside from human forces. That simply does not work anymore. And we need an expanded climate agenda. Yes, we have to reduce emissions that are causing so much of the trapped heat on the planet, but we also have to do more. We have to remove legacy emissions, and we have to repair these damaged systems. And lastly, we are going to need many, many, many more innovators and thinkers and brilliant people from across all disciplines. So I've had the good fortune of working on a range of different systems in my career, starting in the tropical rainforests of Latin America. I spent 10 brilliant years in the Southwest working on rivers and canyons and forests. I went from there to the Puget Sound estuary, which is a spectacular place, and then the last 15 years working on the global ocean. And regardless of which of these systems you take, if you work in conservation, your task is fairly simple. You identify the critical drivers of change, and then you try to figure out how to ameliorate those. It's really quite simple. So let's take an example from the rainforest. When I first started my career, slash and burn agriculture was one of the most critical things affecting primary forests. People driven by poverty and need would come into tropical forests and cut down the trees, burn the biomass, and then be able to grow crops for 2 to 3 years at most because of the poorness of the soil. So we worked with people to try to improve the approaches that they took to agriculture using conservation techniques and allowing them to stay in the same place for multiple years rather than having to slash and burn. So it's an easy example. You identify a forest, you find innovation and approaches to deal with that forest. It gets a little more complex in a place like the Puget Sound, where there are 6 million people surrounding this amazing marine resource, and everything they do, from deforestation in the upper parts of the watershed to urban and suburban development to things directly in the water like overharvest, all of that affects the system, and you have to work on all of it. So it's all about managing the human footprint. That's what conservation is. And let me just give you a really simple definition of the human footprint. It starts with the number of people. You multiply that by how we acquire natural resources and transform them into all of the things that all of the people on this planet are demanding in their daily lives. And then what happens with the waste, right? It's a fairly simple equation, but on the bottom is technology. That is the variable that allows us to have a bigger impact on the impacts of that human footprint. Now, we've tried for years to change the top part of this equation, and the reality is we have not done so well, right? Those things just keep increasing. But what we have done well is been able to affect the equation by the application of technology. I'm not necessarily a techno-optimist. This is just a reality. This day's session is all about human ingenuity, and we are going to need new and bold and expansive ingenuity to solve this problem. Because the sum total of all of that activity and the biggest driver of all on the planet is this: CO2. This is a graphic that shows 800,000 years of climate data. This is from NASA. And in those 800,000 years, this is atmospheric concentrations of CO2. They fluctuated between about 180 parts per million and 300 parts per million. And that was the difference between ice ages. And that happens very, very slowly over hundreds of thousands of years. Now fast forward and you look from 1950 up, and we're on a rocket ride up. We are now 50% above the highest levels of atmospheric CO2 recorded in the past 800,000 years. Some people say in the last 4 million years. So this is a giant experiment with the Earth system that we have indications of where it's going to go, but we still are not sure how bad it's going to be and how fast it's going to be and how severe. So this is the conservation driver, the mother of all conservation drivers, the thing that we have to deal with. And it's driving this enormous heat that's going into the ocean, staying trapped in the biosphere, but mostly in the ocean. And I show this slide mostly just to show the Arctic region. Look at those extreme anomalous temperatures in the ocean around the Arctic. And that is because of this Arctic amplification problem that I'm going to talk a little bit more about. So you might say, well, we're going to solve all that through emission reduction. How well is that agenda working? This is the 2024 Statistical Review of World Energy. We set a new record in 2023, surpassing the record that we set in 2022, and that trend has been going on for a long time. And with the changes that we see in politics in the US, don't expect that to slow down soon enough. And it's not just about political leadership. The world's largest banks have invested something like $6.9 trillion in new fossil capacity since the Paris Agreement was signed. And about half of that is to expansion companies, companies looking to find new oil and gas. So we argue that while we have to absolutely continue to drive as fast as we can to reduction, we are going to need a more comprehensive agenda if we're going to try to win this fight. So it starts with reduction. We've got to bring a whole lot more attention to trying to move this transition to a low-carbon economy, but we also have to work on removing very large amounts of legacy carbon pollution. There's 2 trillion tons of carbon pollution in the atmosphere since we started the Industrial Revolution. It's long-lived. We have to start to pull that out in order to stabilize the planet, but we're also going to have to think about how we repair these critical systems that are being lost that are foundational pieces of the whole Earth system. And lastly, we're going to need many, many, many more brains and much more human ingenuity and the application of new disciplines. So let me just go to the third piece of that agenda, which is repair, and highlight the reason that we need to repair these parts of the system is in large part because of the risk of global tipping points. This report was issued last year at COP 2023. It was done by the University of Exeter. This is the first sentence from a group of 200 scientists. Harmful tipping points pose some of the gravest threats faced by humanity. Their triggering will severely damage the planet's life support systems. More importantly, 5 of them are at risk right now. At current levels of warming, 5 of these planetary tipping points are at risk, and the current approach of linear incremental change will not work. We need exponential change. Now, this is strong stuff from a group of 200 scientists, not normally how you hear scientists talk. This is a warning. The same group of scientists published a precursor paper to this that showed that about 50% of these climate tipping points, this was a smaller number, 16 in this paper, 50% were in the Arctic. So this is the lesson from the Arctic. It holds the key to the stability of the whole planet and the climate system, at least in part. Why is that? As sea ice has been lost, we have opened up an enormous open ocean to absorb all of this excess heat that we're trapping on the planet. This is what's referred to as Arctic amplification, and this is why the Arctic is warming at about 3 to 4 times the rate of the rest of the planet. And so as the Arctic warms, things like the Greenland ice sheet and northern permafrost and the boreal forest and the Atlantic overturning circulation are all put at risk because they're all dependent on the temperatures in the Arctic. So the question is, what can we do about it? We have spent a bunch of time looking at every possible approach that we know about right now, and I want to emphasize that right now, because like Bill Gates famously said about the green energy revolution a decade ago, 70% of the technologies have not been invented yet. I hope the same is true for this case, But what we know right now is there are a series of potential approaches to slow the loss of Arctic ice. I'm going to walk through each of these. They range from very simple Arctic protections, like protecting areas in the Arctic from offshore oil and gas and from ice breaking and protecting the benthic community from trawling. This is all no-brainer stuff that we should be doing right away. Also in the category of no-brainer is managing pollution that is causing accelerated warming in the Arctic, black carbon emissions from wildland fires and from shipping in the Arctic, and also managing these pollutants that are causing warming. So this is the easy stuff to intellectually understand. Less easy, ice management. We have the possibility of being able to slow the loss of ice and rebuild ice. We heard from Fonger about one approach. There are other approaches. This idea of blocking ice export is really interesting. There's a very large amount of Arctic ice that's exported every year through natural processes, through a couple of straits that potentially could be restricted, and we could keep ice in the Arctic. But there's a lot of work to do here in terms of understanding these approaches, building on them, adding to them, and creating new ones. We can also modify the albedo of the surface, and there's a range of different approaches. Again, here, we are not advocating for the deployment of any of these at this point, but for the research and study of all of these and more. We heard about geotextiles in an earlier talk. There's also ways that you can change the albedo of the sea surface itself through microbubbles and other approaches. And we need, again, to really build a lot more attention and effort on analyzing all of these and creating new approaches. And last is solar radiation modification. This is sort of the big outlier that everybody is talking about and worried about, but you can do this in the lower atmosphere through things like marine cloud brightening, mixed phase cloud thinning, and cirrus cloud thinning. A little bit higher in the stratosphere is where aerosols are injected, and then the real space science fiction ideas are these mirrors in space that could potentially reflect sunlight. Some of these may sound crazy, but there's really nothing crazier than standing by while we lose the only planet that we have that we all depend on and that every other form of life on this planet depends on. So it's not crazy to ask the question. So we've developed this tool that you can find on our website. It's a deep dive into all of these approaches, what we know about them, what we don't know about them, what we need to know about them. And if you click on any particular one of these interventions, mixed phase cloud thinning, you'll find pretty much the same structure. What do we know about the approach, the knowledge gaps, first order priorities? You will also find what are some of those priorities. They always focus around research and development and a lot around the enabling conditions. And we are now dedicating our time and effort to putting together a research fund, the Arctic Sea Ice Restoration Research Fund, to fund the critical research and to bring new researchers and new scientists and engineers and AI specialists into the mix. So just to repeat, the lessons from the Arctic: we have to scale up our urgency. We are not working anywhere near fast enough, and incremental change is not good enough. We're going to have to find exponential solutions. We're going to need brand new tools. Protected areas are a conservation tool of the 20th century. They are not going to work as well by themselves in the 21st century. We're going to need some crazy new conservation tools, and we need to think about what conservation even means. I've heard somebody refer to it recently as survival ecology. We need to take more of an approach of thinking about what this planet's going to look like and how we're going to all keep us all alive on it. And we need this expanded climate agenda: reduce, remove, and repair. No single one of those is enough. They have to be done in tandem. And lastly, we need all of you, and we need all of the intellectual resources that we can garner from around the world to tackle this biggest challenge that humanity's ever faced. Thank you.